Hello. Today we're continuing with the college algebra lecture series. This is lecture number 5. And today we will be talking about polynomials. And hopefully after the video, you'll be able to identify the degree and leading coefficient of the polynomial. You'll be able to add and subtract polynomials. You'll be able to multiply polynomials. You'll be able to use FOIL to multiply polynomials, and you'll be able to perform operations on polynomials with several variables. Now, I'm taking the examples and the basic structure of this review from the OpenStax College Algebra 2nd edition, which is free to download, PDF version. There'll be a link in the description. This is section 1.4 from the prerequisite section. So really, these first 5 or 6 lectures, I think 7 lectures, will end up being all review for a college algebra course. So this is good if you are going into a college algebra course. These are the things you would need to know, the prerequisite, so to speak, of the class in most cases. Now, your lecture, your course, your professor might assume different things that you might know, but this is generally the stuff you would need. So let's begin by just defining what a polynomial is. So definition, we'll say a polynomial is an expression of the form, and this is going to be very general, ax to the n, a sub n minus 1 to the xn minus 1. And this will continue to a sub 1 x to the 1 plus a sub 0. Again, this is very abstract, very general. Here, each of the a sub i's is called a coefficient. Coefficient is a math term that means the number in front of the variable. So for instance, if we had 2x squared, 2 is the coefficient, and there's a number in front of x squared. And a sub 0 is constant. It isn't being multiplied by a variable, so we call it constant. The x's, the xi's, let's say, are variable, or variables, each one. Meaning we can replace these x's with some real number, and then the expression, the polynomial expression, will have a value. All right, so we got coefficient. Let's look at what's called the leading term, or a term. So a term of the polynomial are the AIXI in the poly. Is. So an example, I have 3x squared plus 2x plus 1. Each of these we consider to be a term in the polynomial itself. So that's what a term is defined as. The leading coefficient or leading term is the term with the highest degree. The highest power. And the coefficient of that term is the leading coefficient. So our example here, 3x squared plus 2x plus 1, the leading term is 3x squared, and the leading coefficient is 3. X squared is the highest power, 2. X has 1. And sometimes we can think of this as x to the 0 because x to the 0 is just 1. You could look at our previous lectures to get a better grip on the exponents. But that's the leading coefficient in our example. So the first thing we can do is identify some polynomials, and will lead us to our first example. 3x squared plus 2x, 3x cubed, let's say. 2x squared plus x plus 4. So let's identify the leading term. And I put them in descending order, so it's going to be 3x cubed. The leading coefficient, I'm just going to write COEFF, that is 3. And now the degree of the polynomial is the power of the leading term. We call this the degree of the polynomial. So in this case, it's 3. So we have a degree 3 polynomial. This becomes useful later in the college algebra course, knowing the degree of the polynomial. It gets an idea of how many solutions we might have given a polynomial equation. There's also some other useful things about degrees. Degrees will tell us what a graph of the polynomial looks like. A degree 4 has a pretty distinct graph. You can identify a degree 4 poly or degree 3 poly or degree 2 poly. Just by looking at a graph, you can tell what degree it would be. So that comes later in the course. Let's do another quick example here. 19x plus 4x squared plus 4 plus x to the 5th. So here I did not put them in descending order. So the leading term is the term of the poly with the highest degree or highest power. So that's x to the 5th. What's the leading coefficient here? Well, we assume that if there's no visible number in front of x to the 5th, we're going to assume that there's a 1. So x to the 5th is the same as 1 times x to the 5th. Often in math notation, we do not write the most common or obvious. You might have noticed in logarithms, if we were a log of 4 and there is no base, we assume 10. X assumes a power of 1, and no number in front of a variable like x to the 5th, we assume that the coefficient is 1. So the degree of the polynomial is 5. So we have a degree 5 polynomial. And again, the degree 5 will tell us a little bit of what the graph might look like if we were to graph it. And that comes later. All right, let's look at how to add polynomials. It's good to start with the example. There isn't much to this as far as definitions or theorems or corollaries or lemmas. We're just going to take two polynomials, add them. So the key here is like terms. When we're adding or subtracting polynomials, we can only add and subtract like terms. Like terms, again, the term, this is a term, this is a term, this is a term, this is a term. There's 4 terms here. And we have to match variables and match power. So an example, if I have a variable of x, I can only add variables that have x. If x is squared, I can only add variables that have a square. So the like terms mean it has to look the same. They have to look alike. So the first thing we're going to do then is combine like terms. In the previous lecture video here, we did commutative addition in real numbers. So this is why we can combine like terms. The addition's commutative. So I see I have a 12x squared. And over here I have an 8x squared. So I'm going to put those two next to each other. Then I have a 3x. I don't have any other x's, and I have a 19. That's it. We combine like terms. And now we can add those that are the same. The only thing here that's the same is the x squareds. And so we're going to add the coefficients. So 12 plus 8 is 20 plus 3x minus 19. So that's it. That's all we can add. We can't add 3x and 19 because 19 does not have an x. And we can't add 3x to negative 19 because, well, 3 has a variable. So let's do something a little more complicated. Let's say 7a cubed plus 6a squared minus 4a minus 13. I'm going to group those and add that to negative 3a squared minus 4a. Nope, this should be cubed. 4a squared plus 6a plus 17. So the first thing you want to do, again, is combine like terms. I'm going to underline with one line the things that look alike that have a cube. So I got 7 cubed and 3a to the third. Now I'm going to bring the sign. So if there's a negative sign in front of 3, I'm bringing that with. If there's a positive, I'm bringing that with. So that's all of the cubes I can see. I'm going to put 2 lines under the square. And those are all the squares I have. So I'm going to write them 6a squared minus 4a squared. I'll put 3 lines under the a. You can cross these out. You don't have to underline, or you don't have to do anything, just as long as you keep track. So here's the constant terms, negative 13 plus 17. So now you see I grouped them nicely into like terms. So then we do 7 minus 3 is 4a cubed. 6 minus 4 is 2, so that's 2a squared. Negative 4 plus 6 is positive 2a. And negative 13 plus 17 is the same as 17 minus 13, which will be a positive 4. So that's it. That's as far as we can go. We have a cube term, a square term, a term, and then a constant. So there's no more like terms. So this is it. Now subtracting polys is the same as adding. We need like terms. But one difference here is I'm subtracting a polynomial from another polynomial. So an example is 2x squared plus 3 minus x squared minus 4. So in other words, I'm subtracting from 2x squared plus 3, x squared minus 4, the entire polynomial. Now, in a previous video, we talked about how we can think of in the properties of real numbers. If I have x we have x minus y, let's say. I can think of this negative as being a -1. So it's the same as adding -1 times y. Now you might ask, why would I complicate that if I'm just subtracting two things? Well, it's for this particular case. Now you don't have to do this every time once you're comfortable, but I'm going to write it as an addition problem. I'm going to turn that negatives into a -1. And I'm going to do this to illustrate the distribution of -1 through the term x squared minus 4. Because when you subtract a polynomial, you're essentially subtracting each term, which is why we distribute the -1. So then we get 2x cubed plus 3. Now I'm going to multiply -1 and x squared. So that's minus x squared. -1 times -4 is positive 4. So I'm going to add a positive 4. So when we subtract polynomials, we have to be careful. The tendency sometimes with students, the biggest mistake I see is that they subtract x squared, and then in this case, they would subtract 4, forgetting that they have to distribute the negative. Now let's look at like terms. There's only one cubed term. There's only one squared term, but then we have 3 plus 4 is 7. And that's it. Let's do another quick example. Something a little more complicated. I'm mixing variables too. It's easy to use x and y's, but you should be comfortable with any sort of number. So I'm going to use w as a variable here. So the first thing we want to do is distribute the negative sign, or the -1, throughout the second polynomial in order to keep track of the idea that we're subtracting each term. So we distribute the -1. We distribute to each term. So -1 times 3w, that becomes -3w squared. -1 times -6w becomes positive 6w, because negative and negative is a positive. -1 times positive 3 becomes a -3. So when you become more comfortable, you obviously don't have to do these steps where you distribute. If you can just keep track of what you're doing, you can do the distribution in your head. But again, it's one of the most common mistakes I see from students is forgetting to distribute that to all terms. Now we're going to combine like terms. And again, this is not something you necessarily have to write out. I always recommend it when you're starting a college algebra course or intermediate algebra or any developmental algebra course. It helps you, it becomes a habit, and you're far more successful when you have a process, an algorithm that you can rely on, especially when you have quizzes, exams, where you are nervous, where you are a little bit unsure. It helps to have a process. It becomes automatic. So we combine like terms, and we get 3w squared plus 30w minus 3. Okay, so subtracting and adding exactly the same. We need like terms. We perform the operation. With subtraction, the difference is you must distribute that negative to each term of the polynomial you're subtracting. Let's look at multiplying polynomials. And there's a few different ways we're going to look at multiplying. Multiplying can be the most confusing of the operations. So here we're multiplying polynomials. So an example, and again, it's good to start with an example. There's not much in terms of hard rules or definitions here. When we multiply, so we can multiply any terms in a polynomial. They don't have to be like terms to multiply. We can multiply 2x by x squared, even though they're different powers. So what we're going to do is distribute the 2x throughout the polynomial x squared plus 3x minus 17. We talked a little bit in a previous lecture about the distribution property. It's in the properties of real numbers. You should review that if this is a familiar thing to you. But I'm going to write it out literally. So I'm multiplying 2x by each term. So I'm going to do that first by just writing it. And then I'll perform the operation. So I have 2x times x squared. And remember, your exponent rules says that if I have two variables being multiplied, then I'm going to add the exponents. So this is 1 plus 2 becomes 3. 2 times 2x times 3x is 6x. We have a 1 here and 1 here. 1 plus 1 is 2. Then we have 2x times negative 17. So 2 times negative 17 is minus 34, and we just keep the x. So that's how we multiply a monomial, that's a one-term polynomial, by a trinomial, which is a three-term polynomial. We distribute the 2x over the second polynomials, each term. All right, so what if we don't have a monomial? What if we have a binomial? So let's look at that. 2x minus 1, and let's say we have 3x squared plus 9x minus 1. So this is a little different. We're going to distribute again. We're going to use a distribution property. But we're going to distribute each term of this polynomial to each term of the second polynomial. And we're going to do this in steps. So we're going to distribute 2x. Then we're going to distribute negative 1. So in other words, I'm going to distribute 2x to each term in this polynomial. Let's write that literally. Let me write an equal sign here. So that's 2x times 3x squared. I'm just going to put pluses between them. We'll work out the signs once we do the operation. 2x times 9x plus 2x times negative 1. So that's the distribution of 2x throughout that poly. Now we're going to do the same thing with -1. We're going to distribute to each term in the polynomial. And I'm just going to have a long chain of addition here. So it becomes -1 times 3x squared plus -1 times 9x. That looks like an A. Plus -1 times -1. So now we're going to do the operation. So 2 times 3 is 6x cubed plus 18x squared, -2x, -3x squared, minus 9x plus 1. Now we combine like terms, because now we are adding. We are through multiplying, so now we add. So we have a 6x cubed. Here we have 2x squared terms, so I'll put those together. We have 2x terms. I'll put those together, and then we have one constant. So 6x is by itself, and we have 18 minus 3, so that's positive 15x squared. -2 minus 9 is the same as -11x plus 1. Okay, so that's how we combine or multiply two polynomials. So we had a monomial and binomial. Anytime you have, however long your polynomials are, you're going to distribute each term throughout the second polynomial. So if I have a 4-term polynomial multiplied by a 4-term polynomial, I have to distribute each term throughout the second polynomial, which can be ugly, but that's how you do it. In the college algebra course, you're going to learn detached coefficients and some other techniques in which you can multiply polynomials a little bit more quickly. But until that time, that's what you do, distribution. Now, there's one caveat here, and it's sort of a special way to multiply what we're going to call binomials using a mnemonic FOIL. So if you're familiar with FOIL, this will be review. If you're not, FOIL stands for, each letter has a meaning. And this tells us in what way, in order that we multiply terms of two binomials. Now, binomial is a 2-term poly, so a plus b is a binomial. X squared plus y is a binomial. So the way we do this is F stands for first. So we multiply the first terms in the binomial. That would be this times this, first terms. O stands for outside, or sometimes I hear outer. Multiply the outer terms. I don't know if there's 2 T's in outer. In other words, the outer terms are A and Y here. That's why I like outside. Outer sounds odd to me, but I is inside or inner. I'm pretty sure there's 2 N's in inner. And last for L. So the inside terms are this and this. The outside terms are B and Y. So that's what FOIL means. Anytime you hear FOIL, think first, outer, inner, last. First, outside, inside, last. So let's look at an example. And this is a form of distribution. So we are still distributing distribution, but we're going to call it FOIL here. So we have 2x plus 3 times 3x minus 18. But what I'm going to do is use the mnemonic f. So that means I take the first term, 2x, of the first polynomial or first binomial, and I multiply it by the first term of the second binomial. Outside terms. So the outside means that if I have it set up like this, the outside is 2x and negative 18. It's always the outside, however you've written it. If you swap these, you'll notice that the outside term changes, but that means the inside term also changes. So the inside terms are what's together 3 and 3x. And finally, the last term is this and this. So 3 and negative 18. In binomials, this is usually a constant term. So let's do this operation. 2x times 3x is 6x squared. 2 times negative 18 is negative 36x. Inside is 9x. The last term is 18 times negative 3, which is negative 54. So let's put those together here, and we're going to just put an addition. Now we'll keep the sign of the term. So negative 36 plus 9x minus 54. So since 36 is negative, I'm just going to write it subtract, and same with 54. Now we combine like terms. And the way this always works for FOIL is the outside and inside terms will always be like terms. The F and the L will always be single terms. There'll be nothing that we can combine. So you're always going to be adding and subtracting the inside outside terms. So negative 36 plus 9 is a negative 27x, and then the 54 stays out. So that's FOIL. Let's do another example here. Again, we're going to FOIL. It's just a different look, a little more complicated. Just to let you know that they don't have to have a particular look to them. They could be something like this. Now, when we get to the factoring preliminaries, you'll see that there's a way we could factor this first and then multiply, but let's just multiply this. We're going to use FOIL. You don't have to use this technique. You could do it just by combining the terms FOIL in a straight addition subtraction. But just for illustration, I think it's good to use this for now. I'm multiplying the first term of the first polynomial and the first term of the second polynomial. So let's just do the operation. 14 times 2 is 28. Now x squared times x squared is the same base as x, so then we add the exponents. 2 plus 2 is 4. The outside terms is 14x squared times negative 3x. So that is 12, 3, 48, no, 42, negative 42. And x, 2 plus 1 is 3. The inside is 4x times 2x squared. So that's 8x cubed. And then the last terms are 4x minus 3x, which is 12x squared negative. So let's put this all together. We have 28x to the fourth minus 42x cubed plus 8x cubed minus 12x squared. And again, you can see how the inside-outside terms are the only one that are like. So we're going to take negative 42 and add 8, or 8 minus 42, which will give us negative 34 x cubed minus 12x squared. So that's it. And again, if we wanted to simplify it, we could factor some stuff out of this. So look for the factorization lecture coming up. All right, so that's FOIL. Now there's some nice forms we'll call these shortcuts. The first one we're going to talk about is called the difference of squares. If you forget the difference of squares, you can always FOIL. But the definition of the difference of squares is if I have a plus b times a minus b, this will always be a squared minus b squared. So if I see something where the a and the b are just the differences at addition and subtraction, I can just automatically write it as the square of a minus the square of b. So why is this true? Well, if we FOIL this, first terms is a times a is a squared. The outside terms is a times b. So that's negative b. So this becomes a subtraction. The inside terms is a times b. And since these are real numbers, they commute. So I can write them in this order. Instead of b times a, I can write it as a times b. And then last we have b times b is b squared, and that's a negative. And you'll notice these two terms cancel. So that's a squared minus b squared. So again, this is just a shortcut. If you forget, you can distribute and get to the same conclusion. Let's look at an example. X minus 1, x plus 1. So the rule says if I have something that looks like this, really simply, I could just take the first term and square it and subtract it from the second term squared. In other words, x squared minus 1. So that's the multiplication. X minus 1 times x plus 1 is this x squared minus 1. And if you forget, again, FOIL, and you'll get to the same answer. How about 2x plus 7, 2x minus 7? Well, I have the difference of squares. So that means I could take the first term, square it, and subtract it from the second term squared. Well, you notice that's minus the quantity of 7 squared, not plus negative 7. So we're not squaring a negative. So that becomes 4x squared minus 49. So that's a short way to do FOIL. If you recognize, you in the factorization lecture coming up, we'll be undoing these, and there'll be some ways to shortcut some factorizations when we have special forms. All right, so lastly, we want to look at polynomials with several variables. So in college algebra, you're not just going to be working with x's, you'll be working with xy's. That's 2 dimensions, sometimes xyz, 3 dimensions. So we could have multiple variables in a polynomial. And then what do we do? How do we handle that? Well, the rules are exactly the same. An example is 3x minus 1 times 2x plus 7y minus 9. So you notice here we have a y and an x. So we're going to use the distribution that we learned. We're going to distribute the 3x to each term, and then we're going to distribute the negative 1 to each term. And we're going to write that as a long string of addition. So 3x times 2x, we're going to add that to 3x times 7y. And we're going to add that to 3x times negative 9. So that ends the 3x distribution. Now we're going to distribute negative 1. So negative 1 times 2x plus negative 1 times 7y plus -1 times -9. All right, so that's the distribution. We distributed 3x and distributed -1. Now let's perform the operation. So 3x times 2x, remember we can multiply any term together we want. There's no restriction there. That becomes 6x squared. 3x times 7y. We can multiply the 3 and the y, that becomes 21. Now, I can't combine x and y like I would if it was 3x times 7x. That would be 21x squared. So instead, we just write it as a product x times y, because that's what's happening. So we don't write that any other way. If there was y squared or another combination of terms, we can look at in another example and see what we get. But you're going to write them as a product and combine like terms. I'm sorry, and if they have the same base, add the exponents. But otherwise, you're just holding on to the variable. And finally, 9. All right, so we have 6x squared plus 21xy minus 7x minus 2x minus 7y plus 9. So the only two things that are like are this x's here. So we're going to combine those because they are like terms. So that's negative 29x minus 7y plus 9. So we cannot combine any other of these terms. So we are done. All right, one more example. Let's use some other variables here. I'll use a and b. Typically, we don't use a and b as variable, but again, it's just so we get more comfortable with looking at different variable letters. So I'm going to distribute here b squared over each term. And I'll write that literally. Again, if you get good at this, you could just do this in your head. But till that time, be careful, because it's easy to forget terms, skip terms, miss signs. All right, now we're going to distribute -1 through each of the terms. So -1 times a squared plus -1 times 2ab plus -1 times b squared. Often find that college algebra students try to minimize how much they have to write. This is a bad strategy. You should always write as much as you can until you're comfortable with the operations, right? Until you've created an algorithm, so to speak, a process by which you do these things. Only then should you shortcut yourself here. All right, b squared times 2ab becomes 2ab. Now, b is the same base, so I'm adding 2 and 1. This becomes a cubed. This becomes b to the 4th minus 2a squared minus 2ab minus b squared. From a previous lecture on exponents, we can write a squared b squared as ab squared plus 2ab cubed plus b to the 4th minus 2a squared minus 2ab minus b squared. So are there like terms in here? Can we add any of this stuff? Turns out no. This is it. This is a multiplication of polynomial. We cannot add it. So this is it. All right, that's all I wanted to talk about today. We'll say end. Now next time, the next lecture will be about factoring polynomials. Multiplying polynomials, one direction. Factoring polynomials is sort of undoing a distribution, undoing a FOIL. It's going the opposite direction. So the next time we will look at that. This ends this lecture. Please like and subscribe. It helps us out. Comment if you can. And I hope you have a great day.